As we begin, let's first of all define these ratios. You have sine, cosine, and tangent. Sine is defined to be the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. Remember I said earlier that a lot of teachers will use this little saying, SOH-CAH-TOA. So is for sine, and it's OH for opposite over hypotenuse. CAH is for cosine, and the AH is for adjacent over hypotenuse. TOA is for tangent, and it's the opposite over the adjacent. There's another saying, if you prefer it instead, says Oscar had a heap of apples. Here's your sine, Oscar had. Here's your cosine, a heap. And here's your tangent of apples. Now, when we're talking about adjacent and opposite and hypotenuse, that's going to change in every triangle based on your location. Here's what I mean. Let's take a look at this one right here. If I'm looking in terms of angle A, and I want to define the sides of this triangle, well, first of all, we know this is always the hypotenuse. It's across from the right angle, and it will always be the hypotenuse. The opposite would be over here. Think about if you go to the opposite side of the street, or you're sitting on the opposite side of the table. You literally would jump across the table or go across the street. Adjacent is who you're sitting next to. So they're sitting next to this side. Sometimes students will think, well, wait a second, I'm sitting next to this side too. And that's true, but remember, this is the hypotenuse and can be nothing but the hypotenuse. Now, if I'm talking about B as my reference point, then if I'm going to label the sides of the triangle, once again, this has to be the hypotenuse because it's across from the right angle. Then the opposite side becomes this side if I'm referring to this position. Remember, I'm going to go to the opposite side of the street. Then adjacent is right here. It's who you're sitting next to. So let's go ahead and begin with some examples and putting this content into practice. Look at problem number 9. It says right triangle ABC and its side lengths given in inches or below. What is the sine of B? So the sine is what we're looking for. Sometimes students will quickly write down the SOH-CAH-TOA so that they have it. We want sine, which is opposite over hypotenuse. B is our location that everything stems from. So the opposite would be over here. You're jumping clear to the opposite side. This is my hypotenuse. So it's B over C, which is going to be answer D. This number 20. This time it's asking us for the tangent of B. So again, if you see a trig problem on the ACT, maybe you would just want to quickly write out your SOH-CAH-TOA relationships. We want tangent, which is opposite over adjacent. B is the location from which we're going. So opposite is going to jump clear to the opposite side. Adjacent is who you're sitting next to. So it's 1 over the square root of 2, or answer H. Let's take a look at this one. On this one, we're going to draw the triangle out. It says, for an angle with measure theta, that's alpha, and a right triangle, the sine of alpha is 4/5 and the tangent of alpha is 4/3. What is the value of the cosine of alpha? So let's draw a triangle. So make sure you draw a right triangle. Let alpha be wherever you want it to be. And speaking of alpha, theta, betas, you will see a lot of Greek alphabet letters with trig. That's because the Greeks are the ones who discovered trigonometry, and naturally they would use their own alphabet. So that sticks around sometimes. Let's label the triangle. The sine of alpha is 4/5. So that means the opposite over the hypotenuse is 4/5. The tangent of alpha is going to be the opposite over the adjacent. The question says, what is the cosine? Well, that's the CAH. That's the adjacent over the hypotenuse. So the adjacent is 3, the hypotenuse is 5, and my answer is B, or 3/5. Now, I drew the triangle because sometimes you're forced to and you have to draw the triangle. But I really want to show you another quicker way that this could have been done. I could have labeled this. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. So if I want cosine, which is going to be the adjacent over the hypotenuse, I simply could have looked at that and said, oh, well, there's the adjacent 3, there's the hypotenuse 5, and I could have gotten my answer of 3/5. So that's a quicker way this could have been done. Let's look at problem 39. This is a little bit of a different way they might ask the question. First of all, they want the value of the tangent of theta. There's a Greek letter again. Don't let it freak you out. Just still work the problem. In order to find the tangent of theta, I got to have a triangle, a right triangle, in fact. So drop this down and close up your triangle. Now, they didn't tell us the sides directly, but they have told us the sides indirectly, because this ordered pair 10-4 tells me from the origin I went over 10 and I went up 4. So those would be those sides. It wants tangent, so that's TOA, opposite over adjacent. Here's your reference point. So go to the opposite side, and then the adjacent is who you're sitting next to. So 4 over 10, which reduces to 2/5. Notice that they have 5 halves on here too. ACT is pretty sneaky. They try to trick you, and that's not very sweet, but that's what they do sometimes. All right, let's take a look at number 33. All right, on number 33, they tell us that the tangent, which is the opposite over the adjacent, is 5 over the square root of 33, or 39, the square root of 39. So on this one right here, I'm going to label my picture. The opposite is 5. The adjacent is the square root of 39. Now, these answers could look a little intimidating, but let's just think for a second. Let's try to use a trick or a tip to get this one faster. You want sine. You want opposite over hypotenuse. You know that the top number, the opposite, has to be 5. So therefore, this has to be my answer. That is the only one that has a 5 on top. You know, on the ACT, you're trying to find the right answer. Realize, though, that getting the right answer sometimes means getting rid of all the wrong answers. All right, let's take a look at this one. A right triangle is shown below. What is the value of the sine of theta? So we want sine theta this time. So that means I want the opposite over the hypotenuse. So here's my opposite, and here's my hypotenuse. I know that 13 has to be on the bottom. So therefore, it's got to be F or H. I know it can't be H because that would be adjacent over hypotenuse and be cosine. So I can use a trick to help me get the answer. Another thing that you might could do is if you look at all your answers right here, you notice that of the 12 and the 13, the only other number you see is 5. So that other side would have to be 5. Now, I do want to show you the Pythagorean theorem because many times you are forced to use it. So let's go ahead and do a little recap on Pythagorean theorem. So if I wanted to find that side just by the Pythagorean theorem, we know the Pythagorean theorem says, and it's only good for right triangles, but it says a squared plus b squared is equal to c squared. That means in words, a leg squared plus another leg squared is always equal to your hypotenuse squared. This is the hypotenuse. These are legs. So therefore, I know that 12 squared plus, I don't know, the other leg, b squared equals 13 squared. You're going to subtract that from both sides. So b squared is equal to, just go to your calculator and say 13 squared minus 12 squared, hit equals, and you get 25. Take the square root, and b is, in fact, 5. Now, on a side note, the Pythagorean theorem is also on the ACT, so that's helpful for other problems you'll solve. All right, let's take a look at this number 44. The question says, what is the tangent of A? So here's my reference point, and it wants tangent, which is opposite over adjacent. Well, on this right here, I need a right triangle. So this one's going to be a little bit more in the difficulty level, but I want you to see all types. Let's drop this right here. And then I do have a right triangle with A, where the opposite is right here and the adjacent is right there. I could use a little tip and see that, well, 12 has definitely got to be in the denominator. So I know it's one of those two answers. So I need to find this using the Pythagorean theorem, or possibly knowing it couldn't be 4 because that's what 4 is. So G is my answer. Again, though, just for Pythagorean theorem practice, if I needed to find that missing side right here, the hypotenuse, I would say 3 squared plus 4 squared is equal to c squared, my hypotenuse squared. On the calculator or in your mind, just type in 3 squared plus 4 squared. We're just trying to save time on the ACT and go as fast as we can. So C is equal to 5. And sure enough, opposite over adjacent is the 5/12. All right, let's take a look at number 25. On number 25, this is one where we must use the Pythagorean theorem. We don't have much of or maybe perhaps not able to. So let's go ahead and find this missing side. So we know that a squared plus b squared is equal to c squared. I'm going to subtract 9 squared from both sides. So b squared is equal to, quickly in your mind or probably on your calculator, just because we need to be fast, you're going to say 15 squared minus 9 squared and get 144. Take the square root, and the missing side is 12 right there. Now, we should just work backwards. Working backwards is definitely a strategy on the ACT, so let's just work backwards. So 4/5, is that the sine of A, the cosine of A, or tangent of A, or is it in relation to B as far as sine or tangent? So let's start with the first one. The sine of A, well, A is right here. Sine would be the opposite over the hypotenuse, that's my saw. And so that would be 12 over 15. It might not look like 4/5, but if I reduce that and I say 3 goes in there 4 times and 3 goes in there 5 times, then I get what they said. So it's nice when you work backwards and it's the first answer. All right, let's take a look at this number 46. On number 46, here's another one that gives us the sine. Ask for the cosine. So if you want to, and we said it's a good idea to write out that SOH-CAH-TOA as soon as you see it's a trig problem. And we're going to want to draw a triangle on this one. So let's just draw a quick right triangle. Let's put our theta wherever you want to. I could have put it up there. It's just my habit to put it down at the bottom down there. Sine is the opposite over the hypotenuse. So that's 2 over 3. I want the cosine, which is the adjacent, over the hypotenuse. I know that 3 is my hypotenuse, and it would have to be in the denominator. So once again, I've got it down to a 50-50 guess if that's all I can do, but we can do more. Let's find the missing side right here. Using the Pythagorean theorem, 2 squared plus b squared is equal to c squared. Remember we said leg squared plus leg squared is always your hypotenuse squared. So I'm going to subtract, and if you want to, you could go ahead and write it out. So I'm going to subtract the 4, take the square root, and I get that b is the square root of 5. So then I know my answer is adjacent over hypotenuse, and it's answer K. All right, on number 24. And if you'd like to, you could pause the video and try this one on your own and see how you do. All right, on this one, let's draw a triangle. We need a triangle A, angle, I'll just let that again be there. We're given that the sine, which is the opposite over the hypotenuse, remember your SOH, so the opposite is 24 and the hypotenuse is 25. We need to find this right here. Although we do know that tangent is opposite over adjacent, so I know 24 has to be on top because that is the opposite. So if 24 is on top, could it be 24 over 7 or 24 over understood 1? We could use the Pythagorean theorem just to verify. 24 squared plus b squared is equal to 25 squared. Subtract that over, and I would truly just quickly, 25 squared minus 24 squared, and quickly put that in your calculator. Take the square root, and b is 7. So therefore, it is 24 over 7, or answer J. All right, take a look at 43. If you'd like to, pause the video, and why don't you try number 43, because it can be done real quickly just using some tips and tricks. All right, this one says the sine is 8 over 17. What's the cosine? Why don't we try to shortcut this one if we can? The sine, opposite over hypotenuse, they want cosine, which is adjacent over hypotenuse. So we know that 17 must be on the bottom. On this one right here, they have made it very easy for us to see what the answer is. D is the only one where we have a 17 on the bottom. Again, this is question 43, but really pretty easy if you know your SOH-CAH-TOA relationships. Now, this right here, don't let this throw you off. This is a little bit more advanced trig, and while that answer's negative, but it doesn't make a difference if you know that or not. You still got the answer, and we're moving on to the next question. All right, these last two are common questions, but they're so simple. They're so simple, and they're so quick. This right here is definitely SOH-CAH-TOA. I can see because I've got sine, cosine, and tangent. Don't let that little -1 throw you off, okay? Still do what you know to do. Here is my angle of reference where the question mark is. This is what I'm given. This is what I'm given. This is the opposite because I'm jumping across the street, going opposite side to get to it. This is the hypotenuse, because it's across from the right angle. Well, according to SOH-CAH-TOA, I know that when they give me the opposite and the hypotenuse, they're talking about sine. So therefore, it has to be F or G. And which one is it? Sine is 10 over 26, not 26 over 10. So see how simple that was? All right, look at this one. They are really trying to mess us up with this, making us think it's going to be difficult, but it's not. In fact, it's so simple. They give us the question right here. They tell us this, and they tell us this. It says it once, and sometimes I'll just read here. It says, which gives us the measure of the angle from the pipeline and the coastline. But you know, they already gave me the question mark to tell me what they wanted to know. So let's use that. Once again, this is the opposite, and this is the hypotenuse. I know if they give me opposite and hypotenuse, I'm talking about sine. So therefore, it could only be that answer. And sure enough, that is the opposite. That is the hypotenuse. Don't stress out about the little inverse ones. You don't need to. All you need to do on the ACT is get the correct answer. If you'd like more help and practice with ACT math prep content, be sure to check out the other videos on my channel. Remember to like and hit that subscribe button if you found this video helpful, and also tell a friend and share with a friend. See you later.